So I did my PhD in the field of astroparticle physics, which is the field that tries to study all the cosmic particles that are created somewhere in the universe and somehow they arrive to the Earth. Scientists have thought and created many different observatories and telescopes to try to look at and capture these cosmic particles that arrive at the Earth. The one that I have studied is neutrinos. So yeah, neutrinos are quite special because it's the only particle in this standard model that only interacts through a force that we call weak force. And as the name suggests, it's the weakest of the fundamental forces that we know of. That means, for example, that neutrinos can be created in the inside of astrophysical objects, escape these astrophysical bodies that are very dense, and just arrive to us. So they really bring very precious information from very, very vast distances, and also from the very inside of these astrophysical objects. So in my research, I try to look at neutrinos, and to look at them, I use a telescope that is being built in the deep waters of the Mediterranean Sea. This telescope is called KM3net. When a neutrino comes and enters the Earth and then goes through the water, if at some point it interacts with the water, this interaction will create some light. The telescope is composed by many vertical lines, and each of the lines has some spheres that contain the eyes that look at the light created by the neutrino. So in my research, what I try to do is to test a possible cosmic origin of these neutrinos. We still don't know which are the sources that create them. So there are regions in the sky where we know there's a big amount of dark matter, for example, the center of the Milky Way. So we try to look at there and see if we have an excess of a flux of neutrinos coming to the Earth, which can possibly be related to dark matter. Regarding the dark matter searches that we try to do with the neutrinos that we detect with KM3net, we could not associate the neutrinos that we observed with a possible dark matter origin. So what we did is to constrain the theory of dark matter that we were using. That means saying what dark matter could not be given the observations that we made.